Okay, and so it's pretty difficult to disassociate the visual response to a salient external stimulus from the attentional orienting response. And we want to look at the attentional orienting response, but that's pretty hard to disassociate. And so look for the attentional orienting response. It's different than the visual response to a salient external stimulus when you're looking at sources of exogenous attention. So now we're going to be looking at exogenous attention, and so that is not basically your visual response to an external stimuli. That is the attentional orienting response to a certain stimuli. And so there's a difference there. And so some people propose that the system that you use for endogenous attention is the same as exogenous attention. It would just be in a different order. And so if you remember, endogenous attention, which is top down, uses the frontal region first and then the parietal region. And so that's kind of a salience map. And then people were thinking that if it was an externally driven, and so bottom up, that maybe it would be the parietal activity first and then the frontal activity, so it would be flipped. And so it would be the same systems, just a different temporal order. And so that was one theory. But then another theory is was done with fMRI, and it was based on invalidly cued trials compared to valid ones, and it showed that there is a right lateralized ventral attention network, and then this right lateralized ventral attention network has different components, and one of them is the TPJ, and so that is the temporal parietal junction, and you can remember that because it kind of sounds like the Amazing Atheist's name. And so TPJ, temporoparietal junction, and it also consists of inferior frontal cortex. And these are responsible for initiating exogenally driven attention, people think. And so to go back over, the first theory was that it's the same systems, just in the reverse order, and the second theory is that there's a ventral attention network, which is right lateralized, which consists of the TPJ and the inferior frontal cortex, and again, the TPJ is the temporoparietal junction. Okay, and so then another theory was done by Corbetta and Schlumann 2000, and they proposed that there is a right ventral bottom-up system and a bilateral dorsal top-down system. And so that would mean that bottom-up, which would be seeing a bright stimulus and then processing it, would be right ventral. And then a top-down, which would be thinking, oh, hey, I want to look for my friend Greg, which would be top-down, is a bilateral dorsal system. And so, again, right ventral bottom-up, bilateral dorsal top down. Okay, and so then based on recent data, this was kind of disproved because people are thinking that the ventral system is not what they think it is. And so they're saying that the proposed ventral system actually responds to not the correct salient stimulus per se, but it responds to task irrelevant stimuli that are kind of similar to what you're looking for. And so this proposed ventral system would respond to things like if you were looking for a green bird, this ventral system would maybe respond to a red bird because it's a bird, it's not the green bird you're supposed to be looking for, but it's a bird in some sense, and so that would be the ventral. And so they're thinking that it's not exactly what they thought it was. The right ventral isn't exactly a bottom-up system. It is in the sense that it responds to similar stimuli, but it's not the correct target stimuli. And this relates to contingent capture.